Oh my gosh, we're gonna die. Alrighty, we are live for the people that are ill. So I'm going to draw a graph here. And I'm going to give you an example of a graph that when I ask you to sketch, I'm going to show you what scaling looks like. So this is going to be time. Oh, I hate this pen. Be time in hours, and I'm going to have 1 hour, 2 hours, 3 hours, and then over here I'm going to have distance, and that's going to be in miles, and I'm going to scale it like this: 55, 110, 165. And this is time 0, and that's distance, time 0 and distance 0, and I'm going to have something that looks like this. So this point is 3, 165. So, grab a ruler, grab a color, and I'm going to connect these two. And this graph, since it's continuous, right? Because as I'm driving, time is continually passing, and I'm going to call this graph, this function, d of t. So if I know a certain time, I can plug it in and know what my distance is. And so I have that orange line, correct? And that orange line has a slope, correct? Slope. Is orange hard to see? It looks hard to see to me. Madeline, can you see the orange okay? Okay, maybe it's just me. And Ethan, how do you compute slope? I got points. In fact, I know this is 3, 165, and this point is 0, 0. So I got 2 points.
y2 minus y1.
So the slope formula is y2 minus y1 over x2 minus x1. Excellent. So in this particular example, the orange line, what would it be? 3 minus 1. Where do you get the 1? What?
What's the other point? There's 3.
Right here. 0, 0.
Oh yeah. 165 minus 0 and then 3 minus 0.
You know, sometimes people speak to us. You know, like, the Y is on top. It's almost godlike. It is weird. Especially when you see it from this angle, okay? Because sometimes I'm not sure. And you're doing wonderful, okay?
So 165 divided by 3.
Do you know what 165 divided by 3 is?
Is it 55?
It is 55, okay? That's very good. 55 what?
Miles per hour.
Miles per hour. Because this is miles, right? And these are hours. Would you agree? So the units of the y for a rate the units of the y over the units of the x. Would you agree with that? I'll say it again. The units of the y over the units of the x give us our rate. I could have, Lillian, miles this way and gallons this way, right? And then I'd have an average rate of miles per gallon. Does that seem to make sense? All right. So, Ma, what kind of speed is this? The slope is 55 miles per hour. It's also a speed. It's also a rate. What kind of speed is it? Not sure? That's fine. Becca.
Is it a constant speed?
Is it a constant speed? Well, am I constantly driving that speed? In my diagram, am I constantly driving that speed?
No, but the slope is constant.
The slope is constant of that orange line. I would agree. Okay? I would agree exactly with what you're saying. In terms of, I started at home. I ended up at my parents' home, which is 3 hours, 165 miles away, and I come up using the slope formula with this 55 miles per hour. Okay? In context of my story, what is this speed?
Average speed.
Okay, this is my average speed. Would you agree? Average speed. Now, Lillian, if this was gallons here, I wouldn't use speed, would I? Because I'd have miles per gallon, correct? So a more general term is average rate. And sometimes it's a speed. Are we okay with that? All right, now, Lillian, I'm going to come up with a different color. I'm going to choose blue. And I'm going to try to do this. Okay? This is always difficult. Did I tell you I failed coloring in kindergarten?
No.
Okay, so in my kindergarten class, there were 9 kids. Okay? It's the very last day of school. And so we have a coloring contest. And Mrs. Mazzell, my kindergarten teacher, showed us what we're going to win, a certificate. And it was cardboardish like. And it was signed by her, the principal, and it had like a metal tinish seal on it. Okay, it didn't come from a photocopy machine because we didn't have photocopy machines back in 1960. Okay, and it was signed by her, the principal, and somebody who I believed was the governor of Minnesota. Okay. 8 of 9 students got coloring awards. 1 stocky, short, red-headed young boy didn't, because he believed in 2 things. 1, that someday black would be a very popular color, and that in no way should anybody be restrained by outlines. So he had taken his crayon, broke it, peeled off the paper, turned it sideways, and colored the entire piece of paper in black and handed it in 30 seconds, where everybody else took 20 minutes and kept within these boundaries. So this little boy was upset, went home crying to his father that he did not get a coloring award like the other 8 kids. And his father, in his wisdom, said, "You shouldn't. You don't know how to color." So, you see my blue line there, Lillian? Right here is a single point. I'm approximately at an hour and a half in my trip. Okay? Would you agree with that? That's not a bad guess for me. All right? And if I go here and go across, I know it has to be a number between 55 and 110. I'm going to choose 60. Okay? Now, if I had you do this on an activity like with my walk with Rosie, 60 would be a pretty good estimate. If Natalie said 65 or she said 57, it'd be a pretty good estimate, correct?
Yes.
If Aaron said 252, that would be a really bad one, right?
Yeah.
Or a negative 17, right? Those are really easy for me to grade. You got that? That's a big hint for down the road, okay? So I could say, for how long, if I'm driving to my parents', okay, at about an hour and a half, I'm getting onto Highway 52, okay? And I'm about 60 miles from my home, okay? How long am I at that hour and a half in this trip?
Just for a second.
Oh, yeah, just for a moment, right? Maybe not even a second. It's almost instant, right? And then all of a sudden, it's an hour and a half and a tenth of a second, correct? And then pretty soon it's 2 hours and it's a moment totally forgotten, right? It might be a moment my wife says, "Oh my God, there's a deer," and I turn to see it and there's no deer, right? Because I had missed it. Or she'll say, "Oh, did you see that?" Okay? Or she's on her phone and I said, "Oh my God, I almost hit that car." Those type of moments that happen, right? We used to call them Kodak moments till Kodak went out of business, right? So I'm leading up to this. What can you tell me about this blue line that I tried so carefully to draw that I actually had to stand up?
They'll only ever touch one point on the line.
Yeah, this is the blue line is called a tangent line. It touches the graph at one point. Okay, it glances off the point. All right, we're gonna maybe tomorrow go in more depth about that. Okay, I think that's a good thing. Anything else you want to say about that? Touches at one point. Touches at one point. Anything else you want to say about that?
It matches the slope,
Oh, what do you mean it matches the slope?
or
What
it has the same slope as the.
slope of the orange line equals slope of blue for those people that don't have colors, okay? So I'm going to call this O. I'm going to call this B. Okay, for you people out there in the nether world. Okay, so what does that mean? So the orange line has an average rate of 55 miles per hour, right? Because Ethan figured out the slope, correct? And then we said that's an average speed or an average rate. So we have an average rate of 55 miles per hour. Is this an average rate of 55 miles per hour?
Yes. Or,
Well, this, and Ethan very wisely said I needed 2 points, correct? Well, I don't have 2 points here. And if I take 60 minus 60 over 1.5 minus 1.5, I get 0 over 0, right?
So it's like,
Well, it looks parallel. It looks like 55 miles per hour because they're parallel, right? They have to have the same slope. And the people that told you that weren't lying to you. So it has to be 55 miles per hour, but it's not an average rate. It's a different kind of rate. Natalie, do you think you know what kind of rate it is?
no, I just said it's just.
Pardon?
I don't know what it's called.
Okay, now I'm going to talk about this again. So this has 2 moments. I'm at 0, 0, and then another moment I'm at 3, 165. And I can use the slope formula to figure out what's my average rate between those 2 moments. Would everybody agree with that? But you said just for a second. So just for a second, I'm going at that rate because as soon as I move to here, I get a little bit more slanty. Would you agree with it? My rate goes up. And even right here, my rate goes up. Correct? If I drew a tangent line here. And then right here, I'm a little bit flatter. Correct? In fact, here I would hope I'm at 0. So this is a rate because it's 55 miles per hour. But it's only that rate for how long? Yeah, we call this instantaneous rate. Which is the slope of a tangent line the speed I'm going at that moment. Does that make sense with everybody? I'll give you the scenario. My wife and I are having a discussion. I'm not attentive to my speed.
Can I have your attention for a few early announcements today? Due to homecoming events, there will be no water polo tomorrow morning. Homework Central will take place today from 3:30 to 5 in the community room. Also, if you do not have your Storm Nation Gold card yet, please stop in the activities office during your lunch today, after school today, or tomorrow morning. You can use the Gold card to get into the homecoming football game free of charge tomorrow evening. Thank you.
Okay, so here I'm driving, and this has happened multiple times. I'm driving, I'm in conversation with my wife for whatever reason. It must be something important. And all of a sudden I look up, and I'm barreling down, and there's a police officer to the side. What's the first thing I do? Look at my speed at that moment. Because poof, I went right by him, and then I slow down afterwards, which is poopy too late. Because this person's got a speed gun pointed. I want to know what speed I was going at that moment, correct? 85 is not good.